Hello friends, welcome to Prismatics online class. In our today's class, we are going to solve question on the board. The question says, state the dimensional formula for a stress. So solution A. We have stress. Stress is defined as what? Force per unit what? Area. Okay, now, and we know that force is defined as what? MA. Mass over what? Mass multiplied by what? Acceleration. All over what? Area. Area is in square. So now let's go. Mass. The dimensional form of mass, we know acceleration. Acceleration is what? Meter per second square, which is length t raised to power minus 2. Close it. All over what? Area is what? Length. That is length times length. That is what? Length times length. This is the same thing as saying that the stress is equal to what? M times L t raised to power minus 2 all over what? L raised to power 2. Now, by a lot of indices, take this in up, we have it as M multiplied by L multiplied by this will come up, the positive sign will change to negative sign, which is minus 2 multiplied by t raised to power minus 2. Now, that is 2. So, finally, dimension of stress is equal to M. This time, this will give us what? L raised to power minus 1 multiplied by t raised to power minus 2. So the stress, the dimension, hence the dimension of stress is equal to m raised to power 1, m raised to power 1, l raised to power minus 1, t raised to power minus 2. That is the what? The dimension of what? Stress. And that is what we need. Okay, now second solution B, we have here strain. Strain is defined as what? The extension over what? Original length. Which strain is equals to what? The dimension of extension all over dimension of what? Length. Now let's go. This is the same thing as length is what? Just length. Extension is also what? Length. All over what? Length. Length will cancel length. The strain is equals what? 1. Hence, strain is a dimensional. So it has no what? Dimension. Meaning that that is no dimension. So strain does not have what? Dimension. It has no dimension. So it is what? Dimensionless. So that is 10. Okay. Now let's go. Finally, let's look at Young modulus. You call it Young modulus, or you call it what? Shear modulus, or you call it what? Elastic modulus. Now, the Young modulus, like this, is equal to what? We call it tensor stress over tensile strain. Now this is the same thing as saying force over area divided by what? Extension over what? Length. Mathematically, Young modulus is F over A divided by extension over what? L, which if you turn it upside down, we have it as F over A multiplied by length over what? Extension. This is the rule of what? Multiplication. That will give us that Young modulus is equal to F multiplied by L, which is FL, all over what? A extension. Okay, now let's continue here. What we are solving is solution C. Solution what? C. Now from here we have that Young modulus is equal to force multiplied by length all over what? Area multiplied by extension. Now which is the same that the dimension of force multiplied by the dimension of length all over dimension of area multiplied by dimension of extension. Okay, now Young modulus is equal to force. Force is the same thing as saying MA, dimension of MA multiplied by L all over what? Area is length times length width, which is L square, dimension of L square multiplied by length is extension is L. So now let's go. By mathematically, you can agree with me that this one will cancel out. We now have that Young modulus is equal to MA all over what? L square. Okay, now where you need to know where acceleration, dimension of acceleration is L raised to the power t minus 2. That is for acceleration. Replacing it here, we have m, which is untouchable, multiplied by length L raised to power 1, t raised to power minus 2, which is acceleration. Multiply it all over what? L raised to power 2. Okay, now taking this in up, this is equal, Young modulus is equal to L mass times length times t raised to power minus 2 multiply by, when this L raised to power 2 climb up, we have it as well L raised to power minus 2. We have collection of what? Like terms. Young modulus is equal to M into what? L times L raised to power minus 2 times t raised to power minus 2. Now collection of what? Like term. By law of indices, we have this to this will give us M into L raised to power minus 1 t raised to power minus 2. And that is the what? The dimension of what? Young modulus. So the dimension of Young modulus is the dimension of Young modulus or Shear modulus or elastic modulus. The dimension, then the dimension of Young slash Shear slash what? Elastic modulus is m raised to power 1 L raised to power minus 1 t raised to power minus 2. And that is how to find what? The dimension formula of what? Young modulus or Shear modulus or elastic modulus. They are the same thing. Anyone they ask you, they are the same thing. And that is how to find it. Thanks and God bless you. Remember to subscribe to my YouTube channels, Prismatic Online Class. Like, share, and comment. Follow me on what? Facebook. The same thing, Prismatic online class. Like, share, and comment. Bye.